Hello and welcome to the channel, Statistics Decoded. In the previous module, you have learnt about the major measures of central tendency. Now let us learn what variability is and the measures of variability such as variance, standard deviation and range. Several researchers stated that standard deviation is a concept they could not understand. This is an attempt to simplify this concept. Please comment. After watching this module, you can clear doubts by posting it in the comments section. You might have read newspaper reports like the following. Indiana 2022, Android users in India spent an average 4 hours daily on their smartphones. The average sleep duration of Indian adult is 7 hours per night. The average height of an adult Indian male is 5 feet and 7 inches. Is this information sufficient to arrive at reliable conclusions? Let us find out. You have previously learned that there are 3 averages in statistics such as arithmetic mean, median, and mode. So which average is mentioned in those examples? Mean, median or mode? Let us take the example of the average height of adult Indian male which is 5 feet 7 inches. If the average mentioned in this example is median, it means that the height of 50% of the adult males is above 5 feet 7 inches and the height of 50% of adult males is below 5 feet 7 inches. If the average in this example is mode, then we can conclude that 5 feet 7 inches is the height that occurs the highest number of times in the dataset. If the average mentioned in those examples is arithmetic mean, then the information provided is not sufficient. We need further information on the spread of the data. So, what is this spread of the data? Let us assume that the average height of 5 feet 7 inches is calculated by measuring the heights of 1000 Indian adult males. What is the variation in height of these 1000 males? Are they very different? Or are they closer to one another? We can find out the average variation in heights of these 1000 males through mathematical calculation. This single value which reveals the average variation, spread, in heights of the 1000 adult Indian males is called variance. The square root of variance is the standard deviation. Look at the following figure which shows the height of 3 groups. As you can see, the figure shows 3 groups with different heights. In the first group, all the 5 students have similar height of 180 centimeters. The second group comprises of 5 students with very different heights. The third group consists of 5 students with heights which are only slightly different. You can see that the standard deviation of the first group is 0 since all the students have similar heights. But the second group consists of students with very different heights and hence the standard deviation of this group is high which 14.14 centimeters. The standard deviation of the third group is low, 1.41 centimeters because their heights are only slightly different. What does this reveal? When the data is more spread out, the variance and standard deviation will be high, and when the data is less spread out, the variance and standard deviation will be low. Now let us learn what variance is and what standard deviation is in detail. What is variance? Variance is a measure of how spread out a set of data is. It is calculated by taking the average of the squared deviations of each observation value from the mean. In other words, variance measures how far each number in the dataset is from the mean and from every other number in the dataset. The more the value of variance, the data is more scattered from its mean, and if the value of variance is low or minimum, then it is less scattered from the mean. Therefore, it is called a measure of spread of data from mean. Variance is also called mean square deviation. What is standard deviation? Standard deviation is a measure of how dispersed the data is in relation to the mean. It is the square root of variance. Standard deviation measures how far apart numbers are in a data set. Variance, on the other hand, gives an actual value to how much the numbers in a data set vary from the mean. If standard deviation is the square root of variance, why we don't take variance as a measure of spread but take standard deviation? Because the standard deviation is expressed in the same units as the data, while the variance is expressed in the units squared. This makes the standard deviation easier to understand, interpret and compare across different datasets. Standard deviation is denoted in Greek lowercase sigma. Always bear in mind that standard deviation is expressed in the same units as the data. If the data is in centimeters, standard deviation is also expressed in centimeters. If the data is in inches, standard deviation is also expressed in inches. The formula for variance and standard deviation is provided here. You can see that variance is the average of the squared deviations of all the values from the mean and standard deviation is its square root. A sample calculation of variance and standard deviation is given here. For easy understanding, the data of 5 students only is given. You have to bear in mind that your actual dataset may contain observation from very large number of sample which cannot be visually inspected. Since the heights are very different, the variance, standard deviation and range are high. That is, the data is more spread out. But in group 3 in figure, the heights of people are only slightly different. Hence the standard deviation is only 1.41 centimeters. Why we square the deviation of each value from the mean for finding out the variance, to prevent negative deviations from cancelling out positive deviations. If we do not square the deviations from the mean, the sum of the deviations would always be 0 irrespective of how spread out the data is. You can see that in the previous table. This is because positive deviations would cancel out negative deviations. Squaring the deviations ensures that the sum will always be positive, which gives us a better measure of how spread out the data is. Why low standard deviation is ideal? Low variance and standard deviations have a number of advantages, including more accurate estimates of the population mean and variance. A low variance means that the sample values are more tightly clustered around the population mean. This makes it more likely that a sample will provide accurate estimates of the population mean and variance. Increased confidence in the results of statistical tests. A low variance also means that the sample is more likely to be representative of the population. This increases confidence in the results of statistical tests conducted on the sample. A medical treatment with low variance and standard deviation is more likely to be effective and safe for patients. This is because there is less uncertainty about how the treatment will affect different patients. Now coming back to our previous problem of average height of Indian male, if the report is about mean, arithmetic mean, we need the standard deviation for getting a clearer picture. And the report should be like this. The average height of an adult Indian male is 5 feet and 7 inches with a standard deviation of 3 inches. But how will you interpret this finding? For this, you need to understand the empirical rule or 3 sigma rule. Whenever we use arithmetic mean and standard deviation, we assume that the data is normally distributed and it follows certain pattern, and that is called the 3 sigma rule. The concept of normal distribution is clearly explained in the next module. So, what is this 3 sigma rule? The 3 sigma rule, also known as the 68, 95, 99.7 rule, is a statistical rule that states that approximately 99.7% of the observations in a normal distribution will fall within 3 standard deviations on either side of the mean. Here, the mean will be at the center of the distribution. In other words, if you have a normal distribution of data, you can expect that about 68%, 34% each on each side of the data points will fall within 1 standard deviation of the mean, about 95% will fall within 2 standard deviations of the mean, 47.5% on each side, and about 99.7%, 49.85% on each side, will fall within 3 standard deviations of the mean. What is empirical rule? As per the empirical rule or 3 sigma rule, our problem, the average height of an adult Indian male is 5 feet and 7 inches with a standard deviation of 3 inches, can be interpreted as follows. Assuming that the data was collected from 1000 adult males, the height of 680, 68%, adult males is in the range of m plus or minus 1 sigma. That is between 5 feet 4 and 5 feet 10 inches. The height of 950, 95%, males is in the range of m plus or minus 2 sigma. That is between 5 feet 1 inch and 6 feet 1. The height of 997, 99.7%, males is in the range of m plus or minus 3 sigma. That is between 4 feet 10 inches and 6 feet 4 inches. That is, the height of 99.7 adult males ranges from 4 feet 10 inches to 6 feet 4 inches. But how 3 sigma rule is framed? For 3 sigma rule to work, the data must follow a normal distribution. Remember, 1 foot is 12 inches. Since height is a normally distributed continuous variable, we can say with some accuracy that the height of majority of the, approximately 68%, adult males in India, population, is between 5 feet 4 inches and 5 feet 10 inches. But for a variable with non-normal distribution, example, income, you cannot conclude with such accuracy. Thus, 3 sigma rule or 68/95 is to 99.7 rule allows us to predict the characteristics of the entire population based on sample statistics if the sample is sufficiently large and representative of the population. The variable must also be continuous, example, height, weight, and follows the normal distribution. Take the next example. The average sleep duration of Indian adult is 7 hours per night. As in the case of the previous example of heights of adult males, we need standard deviation for a meaningful interpretation of this news report. So, if the mean is 7 hours and the standard deviation is 1 hour, we can interpret the report like the following, assuming that the data is collected from 1000 people using 3 sigma rule. 680, 68%, adults sleep between 6 and 8 hours per night. 950, 95%, adults sleep between 5 and 9 hours per night. 997, 99.7%, adults sleep between 4 and 10 hours per night. That is, the sleep range of 99.7% adults is between 4 to 10 hours. The example classifies the sleep pattern of adults into 3 categories using mean and standard deviation. Thus, you can say with some accuracy that approximately 68% of adult male population in India sleeps between 6 and 8 hours per night. You can also conclude that a sizable proportion of the adult male population in India is either sleep deprived or sleep excessively. This conclusion was possible because sleep duration is a continuous variable which is normally distributed. But how could we generalize the findings from a sample on the population? As the sample size increases, the mean and standard deviation will get closer to the mean and standard deviation of the population. Considering that the sample size is very large, say 1000 for these 2 examples of height and sleep duration, and assuming that it is fairly representative of the population, we can generalize the findings from these studies on the population from which it was selected. Hence, we can say with some accuracy that the average height of Indian adult male is 5 feet 7 inches and height of approximately 68% adult males in India is between 5 feet 4 inches and 5 feet 10 inches. This is also applicable for the study on sleep duration. Thus, with a study on a fairly large and representative sample, we can predict the characteristics of the population from which the sample was selected. So, next time when you come across newspaper reports like the following, the average height of an adult Indian male is 5 feet and 7 inches, the average Indian adult sleeps 7 hours per night. Ask which, average. If the answer is mean, ask for standard deviation and apply the 68/95 is to 99.7 rule, 3 sigma rule. Without standard deviation, arithmetic mean cannot be meaningfully interpreted. Here is an example which demonstrates the importance of variance, standard deviation and range, variability. The daytime temperature of 2 cities for 16 days is given in the table. You can see that the mean temperature for both the cities is 26 degrees centigrade. But the variance and standard deviation are very different. Why it is so? Look at the data. The temperature for city A is less spread out, but the temperature for city B is more scattered. This makes the average temperature of 26 degrees centigrade for city B less dependable for arriving at meaningful conclusion. But for city A, the average temperature of 26 degrees centigrade is dependable to arrive at meaningful conclusion. That is, you can say that the daytime temperature is pleasant for most of these 16 days for city A, but for city B, you cannot make such a conclusion since there is wide disparity in temperature for city B during the observed period. The data from the table revealed that the mean temperature is same for both cities, 26 degrees centigrade. But the standard deviation of city A is 1.38 degrees centigrade, which is much lower than the standard deviation of city B, 5.21 degrees centigrade. This means that the distribution of temperature for 16 days is much varied for city B than city A, that is, the city A temperature is scattered around 26 plus or minus 1.38 degrees centigrade C for most of the days, while city B temperature is scattered around 26 plus or minus 5.21 degrees centigrade for most of the days. Remember 68/95 is to 99 rule. The range of the temperature is 7 degrees centigrade for city A and 21 degrees centigrade for city B. This means that taking average temperature of 26 degrees centigrade is meaningful in the case of city A, but for city B, mean temperature of 26 degrees centigrade does not have much meaning. In other words, arithmetic mean does not give a clear picture of the entire data set and hence it is not truly representative of the data set in the case of city B. This indicates that city A has a homogeneous distribution of temperature and temperature in city B is not very homogeneous. That is, the temperature in city A is less scattered while the temperature in city B is more scattered. Variability is a very important concept in the study of statistics. With our measures of variability such as variance, standard deviation and range, we can determine just how meaningful our mean is. Conclusion: variance, standard deviation and range are all measures of variation in a data set. Variance is the average squared deviation from the mean. It is a measure of how spread out the data is. Standard deviation is the square root of the variance. It is also a measure of how spread out the data is, but it is easier to interpret because it is in the same units as the data. Range is the difference between the highest and lowest values in the data set. It is a simpler measure of variation than variance or standard deviation, but it can be less informative when used alone. Now reinforce what you have learned in this module with some questions. The right answer is also provided. Thank you. In the next video, the concept of normal distribution and measures of divergence from normality such as skewness and kurtosis are explained in a very simplified manner. If you find this video interesting, please comment, share and subscribe for more videos like this. Thank you. In the next video, the concept of normal distribution and measures of divergence from normality such as skewness and kurtosis are explained in a very simplified manner. Watch.